So for our project, we decided to do a little sports analytics and explore the relationship between hitting and pitching and which is more valuable.
Now we are moving on to the executive summary. Basically, we have 5 main parts here. First of all, we are going to talk about our business problem. And our business problem is what is a better investment for the team, hitters or pitchers. Then we are moving on to our measures. We are measuring our team winning percentage first off, like 3 parts. The first part is about hitters. We are using the variables like hitters batting average, home runs, OBP, and strikeouts. And then we will consider about the pitchers. And we will consider pitchers' ERA, strikeouts, WHIP, which is work, hits, BS, inning pitched ratio, and home runs given up. And the third part is the years. And we choose our data from the website baseballreference.com to analyze all data. The 3 methods are time series analysis, correlation matrix model, and multiple regression. And from our data, we can conclude that pitching is more crucial to team's success. Although hitting has more significant stats, pitching has by far the most significant one in ERA.
Alright, so motivation and context for this project. In a perfect world, the front office of a baseball team would like to get as much value for their money as possible. That means knowing what players and positions are overrated and which are underrated in terms of value. So let's say you're a general manager and you're trying to sign a free agent. Your options are a hitter and a pitcher who both cost the same and have had the same performances throughout their careers. So who do you choose? This analysis should tell us what the better option is in terms of value. And then sports gamblers are always looking for ways to find value in their matchups and their picks and a way to kind of gain an edge over Vegas and the casinos. So do you look at a team's hitting or do you look at their pitching when looking at different matchups? Which one has greater importance? This analysis should tell us as well who and what bettors should look at when they're making their picks. Should you take the team with great pitching or should you take the team with great hitting?
So now we are moving on to our business problems and analytical questions. Again, I mentioned in the previous slides, our question of interest is which is more important to a team's success, hitting or pitching. And we connect our problem with some analytical ones. First, which side has more significant p-values? And second, which sides have more significant or relevant coefficients? And then we will have some detailed questions to follow our data. So next, we are going to move on to the assumptions which we made for the data. Basically, we just have 5 assumptions, and the first one is the data is assembled and is representative of the population. And we choose our data from the website baseballreference.com, which is very accurate and up-to-date. Next, so our sample has normality, linearity, and homozygosity and independence. So other factors such as players' health and coach could also be influential in the data. The last assumption we made is certain stats which we not test for can also be attributed to the winning percentage.
So next we are going to talk about our data. Like we mentioned before, we find our data from the website called baseballreference.com. And about our size, there are 1,350 total data entries and 9 different variables, that is including a year dummy variables. And there are 30 teams and 5 years we analyzed it from 2014. So what's in the raw data? In the raw data, there are 8 most important statistics in the game of the baseball for both hitters and pitchers. And about the continuous response variable to estimate the beta is the winning percentage, and that is the continuous response variable. And for the independent variable, there are hitters batting, average HR, OBP, strikeouts, pitchers, ERA strips out WHIP, HR given up, and years about the dummy variables. And for our methodology, we use three methods to analyze the data. The first one is correlation matrix model, which determines if there are any correlation in our dependent variables. And next, the second one is the multiple regression. This method will determine to which variables they are significant and to determine the final equation that would predict winning percentage. And the last one is the time series model, where we are going to determine how winning percentage changed over time and if the independent variables change with it. Here are four assumptions for the multiple regression. The first one is the relationship between the winning percentage and independent variables are linear. The second one is constant variance and normal distribution of errors with mean zero. The third one is there are no multicollinearity that is tested and removed. The last one is the data set is greater than 30, so we decided to use the central limited theorems.
Here are a couple alternatives to the multiple regression that we used. One was a simple linear regression, which wasn't quite appropriate to our data set since we had multiple variables, and this wouldn't be able to track the complexity of our data set that we used. The other one was a chi-square testing. This wasn't appropriate either because this testing is more for categorical variables, which doesn't apply again, so we did not use either of these. For our time series analysis, we looked at the data sets over 11 years for the Red Sox, and we wanted to look at their different winning percentages over those 11 years. Overall, we didn't see much of a pattern at all. There was regular fluctuations or irregular fluctuations in their win percentages, which could be attributed to different players they picked up or different staff in the front office. So about every 5 or 6 years they tended to reach a peak. After that it might go down, but the data was a little too inconsistent to actually display a consistent trend. We used 4 forecasting methods to try to see what the 2019 Red Sox percentage of wins will be. Those different forecast methods were the naive, the moving average, historical average, and exponential smoothing. So we used all these and tried to predict what the 2019 will look like for them. The naive was a 0.667. The 2-year average is a 0.62. Historical average at 0.55. And exponential smoothing was a 0.569, excuse me. In order to find which forecast was the most reliable for us to use though, we used the mean squared error to see which one had the largest error. And then the smallest error was obviously the one that we would likely go with. So for naive, we had a 0.0086. 2-year moving average, we had a 0.0067. Historical, we had a 0.0061. And exponential, we had a 0.0068. So since the historical average had the lowest mean squared error, we deemed that one the most consistent and the most likely to be correct.
Going into this, we thought that there would be a couple variables that were going to be significant. So, for example, we thought hitters' batting average was going to be significant, as well as ERA for the pitchers. And we determined that if the p-value was lower than 0.05 for those, then they would be deemed significant.
Alright, so first we tested our data for multicollinearity, and we found a couple things. So, for the hitting statistics, batting average was multicollinear with on-base percentage, and ERA was multicollinear with both pitchers' WHIP and home runs given up. So it might make sense to remove ERA since it's multicollinear with 2 different variables, but we thought that would be a very important part of our project, a very important variable. So we decided to keep that and look at other remaining variables that were multicollinear to remove. So WHIP had the highest p-value, so we figured that would be the best one to remove. So after removing that, we did another check and we still had some multicollinearity. The other values remained pretty unchanged. So batting average was still multicollinear with on-base percentage and ERA with home runs given up. So between the hitting statistics, on base percentage had a much higher p-value than batting average, and those were much higher than the pitching statistics. So on base percentage had to be removed. And then we did one more check of multiclinearity, and all that was left was ERA and home runs given up that we had to deal with. So ERA had a much lower p-value than home runs given up. So home runs given up was the most obvious choice to remove. So we removed that from our data, and we were clear in terms of multiclinearity.
So first we tested for multiclinearity to determine if any of the variables were correlated with each other. Once we removed those, then we were able to perform a multiple regression. We had several variables still left, and we removed the ones that had high p-values because those were insignificant. Once we got down to our final ones with all the p-values that were significant, we determined that that was our final model, and that was our equation. So next we needed to prove our assumptions. So the first we had to prove that it was a linear relationship. So we looked at our residual plots, and they seemed pretty normal, as you can tell, and we also used our final equation to determine that it was in fact a linear relationship. Next we had to look at make sure that the variance was constant and there was normal distribution of error and it had a mean of 0. So first we looked at the residuals, averaged them out, and it was a very low number, near 0, so we're good on that. And then we made sure that the variance was relatively equal and that it was normally distributed, which it was, so we had no need to adjust anything. Like we mentioned before, we tested for multiclinearity, got that all squared away, and then for the central limit theorem, we had 150 rows, so that's well over the limit of 30, so we're good on that front as well.
So we went with the 95% confidence level because that's the most commonly used and accepted one. So, and as you can see, our coefficients here for the final 5 variables that we finished with. So you got your intercept, batting average, home runs, ERA, and years. And they all have really low p-values, but what you might notice is batting average coefficient is really big. So you might think batting average is by far the most significant, but that's actually not the truth. You have to scale it down a little bit to actually understand the real meaning. So we scaled it down to relative units, and these aren't perfect, but it's just an estimate to give us kind of a look into what these coefficients actually mean. So the batting average and home runs, they actually turn out to be not near as significant as ERA, and we'll explain that. Our final R-squared value was 86.4% compared to the original 86.8 that we started with, and these both maintained higher than 80% level, which is satisfactory. And these basically interpret to mean our independent variables in our final regression explain about 86.4% of the winning percentage for MLB teams. And some of the weaknesses of this project in our data, there's so many statistics in baseball that we definitely probably left out a few of the important ones that impact winning percentage, and we only went back 5 years with our data. So there's a lot more time that baseball has been played, and that we could have collected maybe more data to predict winning percentage. And there's also many other variables that may not be quantifiable, such as team health or team morale. So those are just a few of the weaknesses for our project and our data. So to answer our analytical questions, as far as which side has more significant variables, yes, it's hitting, but that doesn't tell the whole story. Pitching actually has the most significant variable, which is the bigger story here. So while hitting has more, ERA actually has 2 times the impact rather than batting average, and 10 times the impact of home runs hit. So pitching is actually a better investment for teams. General managers and front offices should look to sign more pitchers and less hitters, and sports bettors should pick more of the teams with better pitching staffs rather than better hitting staffs.